guys to put the finishing touches on it. While we are doing that, oh, take down your dividers and put them in the different places where you got it, please. We don't need those up. I'm gonna go ahead, I haven't run off, so I'm gonna go ahead and give you a review sheet. We aren't anywhere near ready for this, but since I haven't run off, I'm giving it to you, so you'll be responsible for it. The answers to this and another whole review sheet are in Schoology. I only need one copy of the paper, but the other one is in Schoology, so when it comes to test time, you can certainly do that. While you have this paper out there, I did not delineate the calculator and no calculator problem, so I want to do that now. Okay, so take your pencil or your pen, whatever you got in your hand, should be a pencil, and mark these problems. These will be the problems that you can use a calculator for. Okay, so here we go. Obviously, please mark these. 1A, just put a little star or a C by him or something. 3, 10, 11, 16, A and B. 17, 19, and 20. Those are the problems that you will need a calculator for. Okay. Now, we're in our notes, and we are going to do that tide problem, if I can find my notes. There we are. All right. So before we attempt to answer the questions, we're going to draw a picture of this situation, and we're going to write an equation for it. Okay? So I'm going to draw a picture of it. Here I go. High tide occurred at 9:36. Now, to make my life a little easier, I'm going to think of these times decimally instead of as 9 minutes and 30, or 9 hours and 36 minutes. So 36 is what fraction of an hour? 36 60ths would be 6/10. So I am going to put high tide at 9.6. And that high tide mark is 2.7. Everybody understand what I just did with my minutes? I don't want to mess with minutes, so I'm going to use decimal hours. All right. Low tide is at 3:48. Okay, 48/60ths is 8/10. Is that right?
Yeah.
So that's going to be, oh, don't put 3.8. We'll have to put 15.8, like military time, because that's PM. And that's low tide, and it is at 2.1. Okay. Assume that the depth of the water is sinusoidal, so in other words, if I graphed more points, it would be looking like a sine or a cosine curve. And the period is 12 hours and 24 minutes. So the period is 24 minutes is 4/60ths. 4/10. Is my math okay? Okay. All right, so let's go ahead and sketch this in. Now, that means that every 12.4 hours, this thing repeats itself. Okay? So, I'm going to move this one over a little bit. Where is there another low point back here? There's going to be another low point back here because it's 12.4 units from low point to low point. Would you agree with that? So if that low point's at 15.8, won't I have another one at 3.4? And I could put another high point out here. Where would that other high point be? The next high point. Remember, the period is 12.4. So that means the distance from here to here is 12.4. So what would that be? 22? Now remember, these are decimal hours. So what does 22 really stand for? 10 p.m.? Right? In order to graph this, we have to understand you can't put 3 a.m. and 3 p.m. on the graph with the same number. Okay. All right, so I'm going to go ahead and sketch this in. Okay. Now I'm going to write an equation for that. And when I write my equation, think about what we did yesterday. We have a number out here in front that controls the amplitude. Then we got to pick a function. That could be a sine or a cosine. The way I have it drawn starting here, would you agree that kind of resembles a negative cosine graph? You have to pick one. And which one you pick is going to determine what parts of your equation look like. Because if you think this is going to be a sine curve, you're not going to start it here. You're going to have to take a different starting point. Okay, so it looks like a negative cosine curve. There's a number here that controls the period. There's a number here that controls the phase shift or the horizontal shift. And then there's a number at the end that controls the vertical shift. So think about what we did yesterday. You were doing a great job graphing, guys. There were 4 numbers that you had to deal with in the problem. You with me? Okay. Now, obviously this thing has a vertical shift. It's been picked up, right? It is oscillating not across the x-axis anymore. Wouldn't you say it's oscillating across that line right there? That's the new axis. What is that? Where is that red line? 2.4? That represents your vertical shift. Would you agree with that? The 0 has been moved up to 2.4. Everything's up 2.4. Well, now you can see what your amplitude is. How high and low, my picture's not perfect by any means, how high and low are these hills and valleys? Well, the whole height is 0.6, but each hill and each valley is 0.3, so your amplitude is 0.3. And we've already decided there's a negative out there, right? Now, normally, your cosine curve would start on the y-axis. Normally, that's that's what a negative cosine curve would look like. This one has been shifted over and it is now starting at 3.4. And since it's been shifted to the right, that's x minus 3.4. Everybody with me so far? Those are the easy ones. Now the period is also easy, but it's going to take a little bit of work. So let's back up and remember what we did when we had another equation. So if we had an equation like 2 cosine 3x, what would you tell me the period is?
Is it
2 pi divided by 3. Remember, for a sine and a cosine, the standard period is 2 pi. It gets divided by this coefficient, right? So we're going to work that backwards. I don't have any idea what this number is, so I'm going to temporarily call it n. You call it whatever you want. But I know that I can get my period by taking 2 pi divided by that number. Agreed? But I know my period. My period is 12.4. So 2 pi divided by n gives me 12.4. So I'll solve this equation. And n is 2 pi divided by 12.4, which is pi over 6.2. Normally, I don't like that, but this is such a mess, we're going to go ahead and just put that in here. That's going to be pi over 6.2. You can turn that into 5 pi over 31 if you want, but I think it's okay just like that. That is your equation.
So, since like cosine and sine are the same shape, could you make a sine equation for that too?
You could make a sine equation, but if you made a sine equation, you would have to start it right here.
Yeah.
And since I don't know that point, could I figure it out? Absolutely. But since I don't know it, it makes sense to me to make a cosine curve, but you absolutely could make it a sine curve.
Okay.
That would not change period or amplitude, but it would change, or it won't change vertical shift either. It'll only change this number and potentially the sign on this one, because what I have drawn starting here is a negative cosine, but if I started here, it would be a positive sign. Does that make sense to you?
Yeah.
Yep. Okay, so there's my equation. Now I'm ready to answer the questions. At what time on the 4th of July did the first low tide occur? All this is the 4th of July. So when did the first low tide occur? Well, we don't really say 3.4. We would say 3 hours and how many minutes? 24 minutes. So 3:24. What was the approximate depth of the water at 6 a.m.? Okay, now wait a second. The depth of the water is the y coordinate, right? X is the time. So if I want to know y at 6 o'clock a.m., I'm just going to put a 6 in here. And I'm going to type that in my calculator. What mode do you think I'm in? Radians. You are in radian mode, and we're going to type that in. Putting 6 right here. Now the parentheses can get a little bit confusing. Do whatever you want, do the best you can. Sometimes you just kind of work it from the inside out, but you do whatever you want. Let's see if we can come up with the right answer. What'd you come up with? 2.32 feet? Or meters, whatever our unit is. Meters. Now I want you to think about that for a second. You should be getting 2.32. Will's question was, can I make this a sine curve? And I said, yeah, but you have to figure that out. That's easy. Isn't that going to be the midpoint of these two? So what's the midpoint of those two? 6.5? Which would mean that at 6:30, it's at 2.4. So doesn't it make sense that at 6 o'clock it's at 2.32? A little bit less? Right? Okay. Now 3 p.m. How deep is the water at 3 p.m.? Do not plug in 3. What do we have to plug in if it's 3 p.m.? Now 6. Don't you guys ever watch MASH? Or some military show? If midnight is 0, noon is 12, what would 3 p.m. be? 15. 15. So we're going to plug in 15. So negative 0.3 cosine. What'd you get for 3 o'clock p.m.? 2.12, which makes sense. Remember, just after 3 o'clock, we're at 2.1, so doesn't it make sense that before, at 3 o'clock, we would be a little bit higher than 2.1? Alana?
Sometimes when I typed in the calculator, I got like 2 points away from where it was.
Okay, well, you're typing it in wrong. So we'll have to work on that, okay? Not right this minute though, but we'll have to work on that. Because I'm pretty sure, did somebody else match my answers? Yeah, I'm pretty sure these are the right answers, they make sense, okay? But we'll look at yours. Make sure you're in radians, and make sure that you're paying attention to parentheses. And you're using your pi button. I don't. I put parentheses here, and then double parentheses that. Okay, last question. What was the first time on July 4th when the water was 2.4 meters deep? The first time that it was 2.4 meters deep. The answer to that question would be 6:30, wouldn't it? Let me double check. Yeah, because it wouldn't be down here. Okay. So 6:30. Oh yeah, I think it would be back here because that distance is 6.2. So it'd be at 0.3, wouldn't it?
Yeah.
Which would be 12. What?
18.
No. 12:18?
Yeah.
12:18.
Which one are you doing?
AM. So Will, you could actually do a negative sine curve and start it there if you wanted to. All right, next, gotta do another one quickly. Okay, we're gonna do the Ferris wheel problem, okay? So here we go, we're gonna do the same thing. We're gonna write an equation for the Ferris wheel. I know that the Ferris wheel makes a revolution every 40 seconds, so that means its period is 40 seconds. here's the Ferris wheel, and here's the ground. The Ferris wheel has a 50-foot diameter, so the radius is 25. And the center of the wheel is 30 feet above the ground. So that's 5 right there. Would you agree with that? So how long after reaching the low point is a rider 50 feet above the ground? Okay, so how high would the rider be at the low point of the ride? At the low point of the ride, he's 5 feet above the ground, right? So at the beginning, let's just assume this is when he's getting on, he's at 5 feet. Now, he's gonna go up, and after 40 seconds, he's gonna be right back down there at 50 feet, correct? What's his maximum height? What's the maximum height? What is the highest the rider is above the ground? 55. And that would happen in 20 seconds. Now, that looks like another negative cosine curve to me. What do you think? Does that look like a negative cosine curve to you? It's obviously been lifted up. Where's its axis this time? 30? The midpoint is 30. So that means that the axis has been lifted, or the whole curve has been lifted 30. Is there any phase shift in this problem? No, it's starting right where it's supposed to, so I'll just put 0 in as a placeholder. You don't need to put that in there, but since I have a blank, I'll put it in there. What's its amplitude? How high and low are the waves? 25? And I don't know what this is, but I know that if I divide 2 pi by it, I get the period, right? And the period's 40. 2 pi divided by this number gives you the period. So it looks like that number is pi over 20. Is that what you got? So my equation is negative 25 cosine pi over 20x plus 30. Oh shoot, I forgot to move this so Dylan could see. Sorry about that, Dylan. We gotta get you back in school. I'm not good at the zooming crap. Okay, so does that look right for an equation? All right, let's answer the question. What was the question? When will they be 50 feet off the ground? Okay, wait a second. Where do we put the 50? So we have to solve the equation. 50 equals negative 25 cosine pi over 20x plus 30. Guys, pay attention. You may have never done this before. Here we go. We're going to solve that equation. Does it make sense to you? We subtract 30. What makes sense that we do next? Divide by negative 25. So I think that's negative 0.8. You with me? Now here's the deal. Do not be confused. The cosine of some angle, forget it, what it's called, that's an angle. The cosine of some angle is negative 0.8. Agreed? So if we just have the equation, negative 0.8 equals cosine theta, how would you find theta? What would you type in on your calculator to find theta? Inverse or second cosine, inverse cosine, negative 0.8. The angle, and again, what it's called is irrelevant. The angle that you take the cosine of to get negative 0.8 is 2.498. Is that what you got? So this angle right here is 2.498. So pi over 20 x equals the number that's on your calculator. So what are we going to do to figure out what plane x is? Take this number, times it by 20, and divide it by pi. When are we 50 feet above the ground? 15.9 seconds. That's exactly right. Woo! That is a doozy-woozy of a problem. Good job. Okay, 4.4 is done. That homework will be due. What's today? Friday? Tuesday. 4.4 is due Tuesday.